All right, everybody, welcome to our Math 3 meeting here on May 12th. So we have completed 8 units of the Math 3 course, and we're now jumping into the very last unit, which will be Unit 9 Statistics. Thank you guys for joining. Again, we are, as we end the this semester, we're jumping into Unit 9 Statistics. We'll have about 4 days on this, so we'll spend the rest of the week talking about statistics in Math 3 and kind of introducing you to some of the topics later on, not today. Today we're going to go through some of the easier topics, and then we're going to jump into some of the harder topics of statistics, maybe some of the things you may see in AP statistics as well. Okay, so this will give you a good jump on that course and your future math courses, as well as statistics around the world. We are going through in Unit 8. We finished with the test yesterday, so I'm going to share my screen with you. On the test, as I share my screen for Unit 8, most people did very well. So if you notice, the scores were anywhere from 80 to 100, but I have 17 turned in. So if you have not turned in and submitted the Unit 8 test, and you're on here watching either live or via recording, make sure that you go back and that you do submit the Unit 8 test. I looked through the questions that people answered on this Unit 8 test, and I did not see any question that more than like 3 or 4 people missed. So there wasn't a question that all of us didn't know. I think there were a few that looked very similar in answer choices, and you may have just picked the answer that didn't correspond with that question. Now, but if you will look at your test and look at your score, see what questions you missed, and go to the paper copy of your test, then you should be able to tell what you missed, and if there is a concept from Unit 8, from exponents and logarithms, that you did not understand. If there is a concept that you didn't get from Unit 8, then send me a message or just let me know, and we can go back to that as well. Okay, so if you'll turn with me, I'm going to share my screen, and you'll turn with me to the Unit 9, which is Analyzing Data. Unit 9 is Analyzing Data, Section 9.1. That should be in your Phase 3 packet. Just a quick reminder, Phase 4, if you haven't seen that out, I don't know if the school sent out the calls yet, but Phase 4 is May 18th for packet pickup for that. And we have a few things to kind of wrap up the semester with when we get to Phase 4. Anything, you do not have to turn in a Phase 3 packet in person. So if you have turned in, if you've gone through the course, and I'll share it with you again, but if you've gone through the Canvas course on here and you go to modules, and if you've turned everything in, some of you have not turned in 8.6, so you need to, but you did turn in the test. So you need to go back and make sure that you've turned everything in from Unit 8. But if you've turned everything in on the packet, then this is the Phase 4, so you don't need to turn it in paper, because I have your responses here on Canvas, and I can go through it that way. Okay, and I'll start adding Unit 9 statistics today as we begin to go through that. So again, you do not have to turn it in person for this class. In another class, you may have to, but for this one, you can turn it in on Canvas. All right, so let's start with, first of all, the main idea of this. This is just analyzing data, so we're going to look at things that you've done in prior classes, and we're just going to go through that. Central tendency. Central tendency means central values or the middle of a data set. So when we talk about central tendency, the most common things that we're using in statistics are the mean and the median. So the mean is the very most common one that you're used to, and that's just the average for a data set. So you get a grade based on your mean, your average scores, right? So your grade is an average. The median is the middle value for a data set when it is listed in order. So be careful there, because a lot of times they're going to give you data that is not in order. Now, what we'll learn from today is that your calculator will put the data in order and give you a median value. And then mode. Mode is the one that occurs the most frequently. So there could be, when we talk about mode, there are three options here. There could be no mode, because none of the numbers repeat. So if all of the numbers in your data are different, then you don't have a mode. There could be one mode, so there could be one number that repeats the most often, right? Or there could be more than one mode. So there may be three numbers that all repeat the same number of times, and so they're tied basically for occurring the most often. So you could have three modes. You could have a multiple modes. So just be careful on that. Maybe no mode, maybe just one, or there could be more than that. The range is the next thing. The range is the difference between the highest and lowest values in a data set. And so basically what that is your maximum minus your minimum. So the range is the maximum value minus the minimum value, and that's going to give you your range. And then lastly, an outlier is a value that is extremely different. So it's very far away. It is extremely different from the rest of the data in the set. So an outlier is a value that is extremely different from the rest of the data in a set. So we go to example 1, and we're going to go to our calculator for most of this. But in example 1, it says find the mean, median, mode, and range. And then it says identify any outliers. So if there's any numbers that are really far away from the others. So I'm going to write down mean, median, mode, range. And what you would want to do is you would want to go to your calculator here for this and put it into a list. So I'm going to share my calculator with you. And where I would go first in the calculator is I would go to Stat Edit. And go to List 1, hit Clear, and hit Enter. And you've cleared out List 1. And now we're going to type in our numbers. 3.4, 4.5, 2.3, 5.9, 9.8, 3.3, 2.1, 3.0, and 2.9. Okay, so we had 9 numbers there in our data. We're going to go, after we've typed it into list 1, we're going to go to Stat. We're going to go over to Calc, one variable stat. So we want statistics on one list. We're going to go down to Calculate. Now, the mean is this top number, the X with the bar over it. We call it X bar in statistics. It's a sample mean. So the mean is X bar. That is 4.13. So 2 decimal places would be fine for this. So 4.13 is your mean. Now, if you scroll down on one variable stats, you see the 5-number summary. Basically, the 5-number summary is how you make a box plot, would be with your 5-number summary. So if you look at this 5-number summary for this problem, the minimum, Q1, the median, Q3, and the maximum. So to get the median, it's right here. It is 3.3. We're going to skip mode for right now, and then we're going to look at the range. For the range, we're going to write 9.8 minus 2.1 equals. and we're going to see what that range equals. That is 7.7. So that is your range. So I'm going to go back to my paper now, and I filled in the mean, the median, and the range. Does anybody have, is there a number on here that repeats in this data set? Do you have a number that repeats? You can answer me. Okay. Said no. Anybody else? Is there a number that repeats here? Do you anybody see a number that repeats? No, I don't see one either. So for mode, you would just say none. Okay. So mode is the one you have to do by hand. Mean, median, range, you can all get from the calculator. Mode, you have to look at it and know if there is a mode or not. So you're going to have to look at it and know if there's a mode or not. So now I'm going to go to outliers. So are there any outliers? Is there any number that you think is kind of far away from the others? Yep, 9.8. I would consider that to be our outlier. So 9.8 would be an outlier. Okay, so that's example 1A. All right, that's example 1A. So in 1B, you're wanting to do the same thing. So we're going to write down mean, median, mode, range, and outliers. So let's do the two things we have to do just by looking at it. Is there a mode here? $19 repeats. Does any other number repeat? I don't see it. So 19 would be our mode. It's our number that occurs the most often. Okay, so now we're going to look at, are there any outliers? Do you see any numbers that are far away from the others? Yep, 0. So we've got, they're all in the tens, right? From 10 to 19 or from 10 to 21. And then all of a sudden we see right after that 14, we see a number 0. So I think 0 would probably be our outlier. So we've got our mode and we've got our outlier. So now let's go to the calculator and we'll get the other three parts. So we're going to go back to stat edit. We're going to go up to L1. We're going to hit clear and enter to clear out that list. And then we're going to type in our data, 17, 21, 19, 10, 15, 19, 14, 0, 11, and 16. Perfect. So in this one, we had 10 numbers in our data set. We go to stat calc, one variable stats, and we're going to calculate it. So we get a mean of 14.2. That's your X bar. Remember, X bar is the mean. The median, you got to scroll down. The median is 15.5. And then the range is your maximum minus the minimum. You want to write that, 21 minus 0, and then what it equals 21, obviously, in this one. So we go back, and you've got all your information. So you've got the mean, you've got the median, you've got the mode, you've got the range, and you've got the outliers. So does anybody have a question on that? Anybody have a question there on mean, median, mode, range, outliers, and how you can get it from your calculator? All right, I think that's pretty basic information. At the next page on here, it says determine how many calls you've made within the past 2 days, record the class data. So what we would have done, if we're sitting in class, we would have taken our class data, wrote it on the board, and then we would have just used that as an example problem. Since everybody's good on these two, then we're just going to mark this one out. So if you'll just take an X and place an X over there, then we'll say we're good with mean, median, mode, range, and outliers. And we'll move down to example number 3. So we'll move down to the bottom. Okay, So let's look specifically at these bottom two problems. Example number 3 says you scored an 83%, a 74%, a 95%, and a 76% on your last 4 math tests. If you want to earn an 85% in the class, what score do you need to get on your next math test? So what we need to do is take the scores that we've made, 83, 74, 95, and 76, and we need to add those 4 scores together to see how many points we actually have obtained so far. Okay, so we're going to say 83 plus 74 plus 95 plus 76. And we've obtained 328 points so far in those 4 math tests. Okay, now we want to have an 85 in the class, and we have 1 more test left. Okay, so let's see. The question is, what would you need to get to make an 85 in the class? So if we think about it, if you have 5 tests, how many possible points can you get from those 5 tests? What's the highest you could score if you on those 5 tests together? 500, right? So 500 is the maximum that you can score. We want to get 85% of that. So 500 times 0.85. So we want to know, what is 85% of 500? So we got our calculator. We say 500 times, and that's right, Hamilton, you are got it. 500 times 0.85 is 425. You got it in the chat there, good. So 425 would be making an 85 on those tests, okay? Now, currently, we have a 328. So to get there, we're going to say, what is 425 minus 328? So how many more points do I need to get to that 425? What do I need to score on that last test? I need to score a 97, right? So 425 minus 328 is 97. So to go over that again, you would add up your scores on the test that you've already taken, and you get that total. Then you would find what grade you want to make. You want to make an 85, so you multiply the 85% times 500, because there's going to be 5 tests. There were 4, and you've got your next math test, so there's going to be 5 tests. So 85. So we want to know how many points is 85% of 500. We get that is 425. We've already scored 328 points on our first 4 tests, so we need to make a 97 on this 5th test in order to get that 85 in the class. Okay. Now, this is a little bit different here in example 4. You scored a 99, a 67, an 83, and an 86 on your last 4 science tests. So we want to add those up. So 99 plus 67 plus 83 plus 86. Let's add those up. What do you get? When you add these 4 tests together, how many points have we scored so far in science? This guy says 335. Anybody else get that? Confirm. Anybody else confirm that? So 99 plus 67 plus 83 plus 86. I got another confirmation there. So 335. Okay, good. So 335 is your score on the first 4 science tests. your next test counts twice. So it's like taking two, right? So it's like taking two. So is it possible to average a 90? So far you've taken 4. Your next one counts twice. So how many total points will you be able to get? Let's say you got 100 on every one. What's going to be our total? 600, right? Because the next one counts twice. Those only counted once. So 600, we want to try to get a 90. So 600 times 0.90. So we'll say, what is 90% of 600? So we're saying, what is 90% of 600? We'll say that's going to be 540. Okay. So 540 minus 335 is going to give us 205 that we need to get on that last test. And we can divide that by 2, remember, because it counts twice. So that means we would need to make 102.5. So is it possible to average a 90? We're going to say no. We would have to make, unless they give you bonus points or something, no, we would have to make 102.5 on the last test. And so basically, there were 205 points left that we needed because we had scored 335 points and we needed to get to 540. So there were 205 points left. The reason I divided it by 2 was because it said the last test counted twice. So just think about if you would have made 100 on that last test, 100 times 2 would be 200. So you're having to make more than 100 is actually 102.5 that you would have to make in order to get a 90. So basically, if you're that person and you've only got that one test left and you're stuck there with a B, you're not going to be able to get your grade up to an A. So that's a way of calculating. I know a lot of you have calculated in the past what you need to make to get your grade to a certain number, and that's what these questions are asking. So these are kind of real life things where you say, oh, well, here's my score. I got an exam coming up. What do I need to make on the exam to get an A or to get a B? And so this is what that is about. So there's example 4. So that takes you through the first page of the analyzing data. So we're going to move on now to page 2. And page 2 takes us to a fairly new concept and one that is used a lot in statistics. And this is called variation and measures of variation. So variation is how spread out something is, how much it varies one way or the other. And the way that we calculate variation specifically in statistics is the standard deviation. The standard deviation is sometimes called S, and you'll see that in your calculator as well when we start to calculate it there. There is also something called the variance. If you notice, the variance is just the standard deviation squared. So the variance is also something that is connected to the standard deviation. It's just the standard deviation squared. So if you know the variance, you actually can get the standard deviation by just taking the square root of the variance. If you know the standard deviation, you can get the variance just by squaring the standard deviation. So they have a relationship there with each other. So on the first page, a measure of variation describes how the data in a data set are spread out. So how far spread out are they? How do they vary? Standard deviation, S, is a measure of how far the numbers in a data set vary. From the mean. So how far do numbers vary from the mean? So like basically the definition of standard deviation is how far on average the numbers in your data, how far on average they vary from the mean. That's the definition of standard deviation. So variance is a measure of how far each value in the data set is from the mean, okay? And that is your variance. So let's look at how we would calculate this. So we're going to go to example 5, and we're going to calculate this by hand. Now, I'm going to note to you that your calculator will actually do this. But what we're learning right now is what standard deviation actually is. So we're going to find the standard deviation of this, and this hopefully will show you and explain what your calculator is doing when it finds the standard deviation. So this is important because you want to actually find what standard deviation actually is. What does it mean in a problem? So let's look at our data set. We have 2, 6, 7, 3, 4, and 2. The first thing we need to find is the mean, the average. So we could put them in list 1 and find the mean. We could just add them up. So 2 plus 6 is 8, plus 7 is 15, plus 3 is 18, plus 4 is 22, plus 2 is 24. And we have 6 numbers. So 24 divided by 6 gives us a mean of 4. So that is the mean. So to do standard deviation, you have to know the mean first. Okay, so the mean is 4. So notice what we're going to do in each of our data values. We're going to do x minus the mean. So let's find what that is. So in the first one, 2 minus 4 equals, that's negative 2. 6 minus 4 equals, that's 2. 7 minus 4 equals, that would be 3, right? 3 minus 4 equals negative 1. 4 minus 4 equals 0. 2 minus 4 equals negative 2. So notice what we did there. What this is telling us, so x minus the mean is basically telling us, is it above or below the mean, and then by how much? So a negative 2 means you're 2 below the mean. A positive 2 means you're 2 above the mean. A positive 3 means it's 3 above the mean. A negative 1 would be 1 below the mean. 0 means you're at the mean, at the average. And then negative 2 would mean you're 2 below the mean. Now, notice what you want to do in this second part. You want to square it. Now, the reason we're squaring it is because, for instance, negative 2 squared is 4, and 2 squared is also 4. So because we're looking at the distance it is away from the mean. So the number 2 is the same distance away from 4 as the number 6. And so we're making everything positive because we're talking about distance, the distance from the mean. So when you square something, a negative times a negative is a positive, and a positive times a positive is a positive. So this is a way of making everything positive so that we're talking about the distance. Okay, so let's keep squaring all these. So 3 squared is 9. Negative 1 squared is 1. 0 squared is 0. And negative 2 squared is 4. Okay, and then it says the sum. So we want to add all those up. So 4 plus 4 is 8, plus 9 is 17, plus 1 is 18, plus 0 is still 18, plus 4 is 22. Okay, so notice of the formula for variance. Okay, this is the formula for variance. Variance equals, this stands for summation, so that means add up all the x's minus the mean squared. Well, that's what we did. We got all the x's minus the mean squared, and we added them all up, and we got 22. And it says to divide them by n minus 1. N would be our sample size. How many things are in our sample? Well, we have 1, 2, 3, 4, 5, 6. So we're going to divide it by 6 minus 1. So that means divide it by 5. So our variance is going to be 22 divided by 5. Excuse me. So 22 divided by 5 is 4.4. And that will be our variance. Now, our standard deviation, if you look at the formula up there, you see the same formula. The only difference you see is it's being square rooted. So we're wanting the square root of 22 over 5. So for standard deviation, we want to take the square root of 22 over 5. So square root, in parentheses, 22 divided by 5. And we get 2.0976, however you want to do it. That is our standard deviation. Okay, so we have the variance and we have the standard deviation. Now let me show you quickly. We just did that all by hand, if you notice. We did this entire thing, example 5, we did this entire thing by hand, right? Well, let's go to the calculator and let me show you how the calculator will do this. So we did it by hand to show you what it really is, but in practice, we're going to use the calculator. So if we type in our data set, 2, 6, 7, 3, 4, and 2. We type that into list 1. We go to stat, calc, one variable stats, just like we did for the other. We go to calculate. Notice our mean is 4. That matches the mean. Okay? Notice this right here. You see S of X. That's our standard deviation, 2.0976. So we would write that down, and then if we wanted our variance, we would just say 2.0976, and we would square it, and that would give you your variance of 4.4, right at 4.4. Okay, so if you put the data in stat edit and you go to stat calc number 1, there is your mean, X bar. There is your standard deviation, SX. And then if you have the mean and you have the standard deviation, you can also, if it wants you to get the variance, all you have to do is square your standard deviation, and you would have that as well. Okay. N, if you were confused about what N was, N is your sample size. That means how many data points do we have? We have 6, and then that is everything on there. Okay. So I can go back to this sheet. If you look down at the bottom, it says the table, example 6 says the table displays the number of U.S. hurricane strikes by decade from the years 1851 to 2000. What are the mean, standard deviation, and variance for this data set? So there's all the decades, but we're looking at the strikes, okay? So we're just looking at how many hurricane strikes there were each year. So we're going to type the number of strikes into our calculator. And in stat edit, you can take a look at the number of hurricane strikes. We had 19, and then we had 15, and then we had 20, and then 22, and then 21, and then 18, and then 21, and then 13, and then 19, and then 24, and then 17, and then 14, and then we had 12, and then 15, and then lastly 14. So these are the number of hurricane strikes each decade. So we can go to stat calc after we've typed those in. We can calculate it, and we have, it's asking us for the mean, the standard deviation, and the variance. So the mean is 17.6. That's the average number of hurricane strikes per decade, 17.6. The standard deviation is the SX there. So the standard deviation is 3.641. Okay, which leaves us with trying to find the variance. So if we know the standard deviation on here is 3.641, then we can say 3.641 squared, and that will give us the variance. That is 13.25, and it would be 7 if I rounded up, 13.257. Okay, so now I can go back to my paper and I write that down. I've got the mean of 17.6. That was X bar from the calculator. Got the standard deviation of 3.641. Remember, that's SX from the calculator. And I've got the variance by squaring this standard deviation. Okay, so what I would like for you to do, this is our only thing, right? Remember, for day 1 of statistics. So for today, what I would like for you to do is go down to the example 7 and the U try. And I would just like for you, we'll mark out B, and we'll mark out, we don't need to know within how many standard deviations it falls. We'll get to that later in statistics. But right now, for Math 3, we want to take, this table displays the number of hurricanes in the Atlantic Ocean from 1992 to 2006. So this is per year, the number of hurricanes. So we're going to type in the number of hurricanes in list 1. For this part in gray, we're going to type into list 1. And I want you to tell me the mean, the standard deviation, and the variance from your calculator. And then down here, same thing. You want to type this data set, these numbers into list 1, and you tell me the mean, the standard deviation, and the variance from your calculator. So if you can do those 3 things, then you are good to go for today, and you will have completed 9.1 analyzing data. So what I'm going to do is take you to the course. In Unit 9, I'm creating an assignment here. It's going to be called 9.1 Analyzing Data. And as you finish these 2 problems, if you'll just go ahead and upload your work from today, and I'm going to put it here where it is an upload. So if you will, I've published this assignment, and if you will put in your work from today and go ahead and upload that to Canvas, then you will have everything completed for today. Now remember, as I said, I think 17 of you had turned in the test. Even fewer had turned in some of these late assignments from Unit 8. So be looking at these and make sure you are turning in these assignments as well from Unit 8 that were in Phase 3, okay? So you can catch up. So today is kind of a catch-up day on that. If you'll finish these 2 problems at the bottom by getting the mean, standard deviation, and the variance, and then you'll go back and make sure you've uploaded everything from Unit 8, then you'll be in good shape. Tomorrow, we're going to work on the homework for this. So we're going to look at an IXL and look at some questions that go with all the parts from your calculator. So if you notice, a lot of statistics can be done in the calculator, but we want you to understand where it's really coming from. So we want you to understand what standard deviation really is. That's why we subtracted it from the mean and then squared it to get the distance, so that hopefully you get a better understanding of what that number actually is. But the calculator is going to be a very big benefit to you in this course, so, and especially in the statistics course.